Hi guys, I hope you are all okay. I would like to welcome you in my electrical technology class. In today's lesson, we are going to learn about DC machines. Okay, guys, by the end of this lesson, you should be able to describe a dynamic break test, describe the Hopkinson back-to-back test, should also be able to describe the Swinburne test, also have to be able to calculate the torque, power, and speed control. Introduction to DC machines. In DC machines, we have a generator, also have a motor. What is a generator? A generator converts mechanical energy into electrical energy. Then a motor converts electrical energy into mechanical energy. Yeah. Okay, let's look. What are DC machines? DC machines converts electrical energy to mechanical energy. Those are motors. Or mechanical energy to electrical energy. Those are generators. They operate on direct current power. They operate on DC power. And key components include armature, the rotating part, field, field windings, stationary part, commutator, and brushes. EMF generated or electromotive force generated. The electromotive force generated in a DC machines depend on these following things. Depends on phi, P, N, Z, and C. Here's our key formula. It says E is equal to P times phi times N times Z all over C, whereby our phi represent useful flux per pole, then P represent the number of pole pairs, N represent the speed, Z represent number of armature conductors. Then C is the number of parallel part between brushes. EMF and potential difference. EMF or electromotive force. It is the voltage when the load is disconnected, or it's the machine's generated voltage. Then the potential difference. Potential difference is the voltage when the load is connected, or it is the terminal voltage under load. Okay, for a generator, we use this formula that says EMF is equal to the voltage plus the armature current times the armature resistance. For a motor, it is opposite. It says EMF is equal to the voltage minus the armature current times the armature resistance. Torque phase method. Calculating torque. Power developed by the armature is equal to the EMF times the armature current. Relationship with torque. Um, Power is equal to 2 pi times T times N, whereby the T represents the torque in newtons meters. The N represents the speed in revolution per minute. Then the E stands for EMF in volts. Then the IA represents the armature current in amperes. The torque second method. Alternative torque calculation. Torque is equal to force times radius, where force on one conductor is represented by force equal to B times L times I, whereby B is the flux density, L represents the length of conductor. Then I is current in one conductor. Then the total torque for Z conductors is represented by T is equal to 0.15 times power times flux times the armature current times Z. The speed control of DC motors. Why control speed? DC motors allow easy speed control. This is one of their major advantages. Speed depends on three factors. Number one, the terminal voltage of the armature. Then the external resistance in the armature circuit. Thirdly, the flux per pole. There are two main control methods. The first control method is the armature control method. Then we have the field control method. Speed control of DC series motor. Armature resistance control. Controlling resistance is connected in series with the motor. Most common methods for series motors used for constant torque applications. Applications are cranes, hoists, and trains. This method is economical for reducing speed under light load conditions. In field control of DC series motors, we have the field diverter method. A diverter resistor is connected in parallel with the series field. Reduces field flux by shunting current around the field winding. Effects are less field current, less flux, higher speed. Provides rapid acceleration. Enables high speed. Used in applications where speed increases sharply when load decreases. Speed control of DC shunt motor. Flux control method. Speed is inversely proportional to flux. A rheostat is added in series with the field windings. Adding resistance reduces flux and also increases speed. Advantages are field current is small, power loss is minimal, method is efficient. Here are the limitations. Weakening flux beyond limit affects commutation. Amateur control of DC shunt motor. Amateur control method. Speed is directly proportional to back EMF. Adding resistance in series with amateur reduces current. Less current results to lower speed. Effect: greater resistance is equal to greater decrease in speed. Relationship is that back EMF is equal to voltage minus armature current times armature resistance. The word Lenard's system, used when very sensitive speed control is needed. Components: M1 is equal to the constant speed motor, AC or DC. Fg, G represents the generator directly coupled to M1. M2 is the motor speed is controlled. How it works: generator output feeds the armature of motor M2. Output voltage can vary from 0 to maximum. This allows very smooth speed control. Applications: electric excavators, elevators, and industrial dives. Examples: speed variation in DC motors. Explain how the speed of DC motor varies in relation to number one, the armature voltage, number two, the field current. Here are the solutions. The armature voltage speed increases with an increase in armature voltage, but not in direct proportion. Field current, number two, the field current speed is inversely proportional to the field current if poles are unsaturated. Another worked example with answers to work on. Moving forward, these fundamental concepts of DC machines, EMF generator, torque, speed control, losses, and efficiency testing are essential for understanding more advanced topics in electrical engineering. The formulas and methods learned here will be applied in subsequent modules covering AC machines, transformers, and power systems. Practical understanding of testing methods, Swinburne and Hopkinson, is particularly important for real-world application in industry. Guys, thanks for watching. Hope you understood on DC machines. If you have any questions, you are free to ask on the comment section.